Celestial declination refers to a sky coordinate. This is a way that we can quantify in our observer-centric space a single value that allows anyone in the world to then know about this object from their perspective. We're going to use December because that's really popular right now with the 24-hour sun. Every year in December, no matter what, the sun has a celestial declination of -23. But how do we know that? Well, it's quite easy. Right now, today, my sun, when it was at the highest point in my sky, it was 50 degrees from my horizon, and it was facing south. So I get my compass out. Your compass is one of the things that you're going to want to buy when you start at the Flat Earth University, so you can kind of estimate these angles of elevation. But I found out that 130 degrees is how high my sun was. Now, the second thing you want to do is orient yourself. This is one of the ways of how celestial navigation works. So for us, we use Polaris if you're in the northern hemisphere. All you'll do is look outside until you see Polaris. For me, it's north and 17 degrees from my horizon. Now, I live in Belize. I have a latitude of 17 degrees north. So because the Earth is flat, your latitude will also be equal to the angle of elevation for your north celestial pole or your south celestial pole. So if you live in latitude 40 degrees north, somewhere in the United States, that would mean Polaris is also going to be 40 degrees from your horizon. So what we do then is we add a right triangle, we offset this, because there's something called the perspective offset. When you're doing flat earth math, dealing with right angle triangles, because everyone in the world needs to use this exact same number to be able to orient themselves. So what we do is we just add 90 degrees to my perspective. So 17 plus 90 gives us 107. Now, the formula for celestial declination, as you're able to see, ends up just being that perspective equator, we call it, because it's the middle of our perspective. There's a middle line that we use to orient ourselves. And all we do is then we subtract that from the initial angle of elevation of the sun we're trying to track. In this case, 107 subtract 130 equals -23 degrees. And if you look in a celestial almanac, any astronomical model, this will be verified. You can confirm that what we just did is true. The celestial declination is -23 degrees. And we just calculated that ourselves by going outside today in Belize. Now, as we started again, so my sun's angle of elevation was 130 degrees. My perspective offset ended up being 107 degrees, and we subtracted those. You can do this anywhere you live in the world. So right now, like check. So tomorrow morning, I guess, when you wake up or go online, use like an app like Stellarium and check when the sun was highest in its sky. This is the zenith point. Check the angle of elevation, do your latitude offset, and then do your Polaris offset. You will always get -23. If it's December, but even today, right now, it's actually about like 22.5 maybe.
Fire signs, textbooks by my bed. She look at me like I'm insane, she look at me. I said